Hello everyone. Today we will learn about divisibility rules. These divisibility rules or tricks works well for everyone and in almost every real life situations. So let's understand what divisibility means. Divisibility in simple words means the capacity of being evenly divided without any remainder. I repeat, it means the capacity of being evenly divided without any remainder. Like 9 can be divided by 3 because it comes in the table of 3. Also 15 can be divided by 5 without any remainder left. These rules simplifies calculations and help reduce the time taken to solve any problems. Because if we follow these rules, we don't have to actually divide the large number by another number as we do it in actual method of division. This may prove fascinating to the kids as not much calculation is required here and they need not be afraid of any large numbers. They can quickly determine if given number can be divided by any small number like 2, 3, 4 and so on without the long division method. So let's start with those tricks. The first one is divisibility rule of 2. Let's understand this with the help of an example. The divisibility rule of 2 says if the last digit of the given number is an even number. What is an even number? 0, 2, 4, 6 or 8. 0, 2, 4, 6 or 8, these 5 are even numbers. So it says if the last digit of the given number is an even number, the whole number will be divisible by 2. However large the number may be, like you can write more digits to it, however large the number may be, it will be divided by 2. Divisibility rule of 3. Let us take example. Divisibility rule of 3 says if the sum of all the digits in the given number is divisible by 3, the complete number will be divisible by 3. It says if the sum of all the digits. So let us take the sum. It says if the sum of all the digits in the number is divisible by 3. Is 21 divisible by 3? Yes, it is. So, if it is divisible by 3, this number will be divisible by 3. Example. Divisibility rule of 4 says if the last two digits of the given number are divisible by 4 or the last two digits are zeros, the whole number will be divisible by 4. So let us fulfill the first condition. If the last two digits are divisible by 4, is 52 divisible by 4? Yes, it is. So this number will be divisible by 4. Also, if the last digits are zeros, like for in this example, last two digits are zeros, 2 zeros. So this number will also be divisible by 4. Divisibility rule of 5 says if the last digit is either 0 or 5. If the last digit is either 0 or 5, so it's a 5 here, the whole number will be divisible by 5. Another example, if the last number is 0 or 5, this number will also be divisible by 5. Divisibility by 6. Example, divisibility by 6 says if the number is divisible by 2 and 3 both, the number will be divisible by 6 also. If the number is divisible by 2 and 3, so let us check by both of them. By 2, the divisibility rule of 2 says last number should be an even number. So it is an even number. So it will be divisible by 2. By 3, the rule says if the sum is divisible by 3. So let us take the sum. If the sum is divisible by 3, the number will be divisible by 3. So this is also correct, and with 2 it is also correct. So if it fulfills both the conditions 2 and 3, it will be divisible by 6 as well. Divisibility by 7. Let us take the example. Divisibility by 7. It says remove the last digit of the given number and double it and subtract it from the leftover number. So let's do it. It says remove the last digit and double it. This is the last digit, let's double it. And subtract this product from the remaining number. This is already taken, so this is the leftover number. This is divisible by 7? Yes, it is. So let us take an example with large numbers. Again, remove the last digit and double it. This is the last digit, double it. So remove this and subtract 2 from the leftover number. Since it's again a big number, we have to continue doing this process till we get a 2-digit number. This is the last number. Hide this. Again a large number, again a big number, 1. Hide this. So we got a 2-digit number. So is 35 divisible by 7? Yes, it is. Right? So this number will be divisible by 7. Divisibility by 8. Divisibility by 8. It says if the last 3 digits are divisible by 8, the whole number will be divided by 8. It says if the last 3 digits are divided by 8. So let us check. Yes, it is getting divided. So if the last 3 digits are getting divided by 8, the whole number will be divided by 8. Divisibility by 9. Let us take the example. It says if the sum of its digits is divisible by 9. If the sum of the digits, so let us take the sum, 8 plus 1, 9. If the sum is getting divided by 9, it will be divided by 81 as well. It is getting divided, so this number will be completely divisible by 9. Another example, take the sum of it. Since 0 has no value, we can write like this. Right. So we got the sum as 9. So 9 is divisible by 9. Right. So this whole number will be divisible by 9. Divisibility by 10. Divisibility by 10. It says if the last digit is 0 in the given number, if the last digit is 0, it will be easily divisible by 10. Another example is if the last digit is 0, right? It will be divisible by 10. Divisibility by 11. 11. Let us take an example. It says to add, first of all, we will allot numbers to the this number. We'll allot numbers 1, 2, 3, 4, 5, 6. We'll give the numbers to this. Now, 1 odd 2 even 3, odd 4 even 5, odd 6 even. So we have to take the sum of them. First of all, let us take the sum of digits at odd places. Odd places is 1, 3, 5. Right. So it's 9 plus 1 plus 6. Now, sum of digits at even places. 2, 4, 6. So numbers are 8, 3, 5. 16. So it says sum of the odd places minus sum of the digits in the even places. Odd is 16 minus even is 16. 0. It says if the answer is, if the difference is 0 or multiples of 11. If the answer is 0 or multiple of 11, the number will be divisible by 11. Let us take another example. We'll add the even places. We'll give the numbers first of all. So even places are 2 and 4. Odd places 1 and 3. So 1 plus number in third place is 4, 5. So we have to take out the difference. So 16 minus 5 is 11. So it says if the answer is 0 or multiples of 11. So this is the multiple of 11. So any of the answers is right. So this will also be divisible by 11. Right. At last, let us take an example and check it with all the divisibility rules from 2 to 11. Divisibility rule by 2 says if the last digit is an even number, it will be divisible by 2. So this is an even number, it will be divisible by 2. Rule of 3 says if the sum of all the digits is divisible by 3. So let's add it. If the sum is divisible by 3, it will be divided by, the number will be divided by 3. So this isn't getting divided by 3. So no. Divisibility rule of 4 says that the last two digits should be divisible by 4. So is 56 getting divided by 4? Yes. So this number will be divided by 4. 5. So it isn't 0 or 5. So no. Divisibility rule of 6 says it has to be divided by 2 and 3 both. By 2 it is, yes, it is getting divided by 2 because it is an even number, but it isn't getting divided by 3. So if one conditions fail, it won't get divided by 6 either. 7 says remove the last digit and multiply it by 2. Again. So is 8 getting divided by 7? No. So this number will not be divided by 7. 8 says last 3 digits should be divided by 8. Divisibility of 8 says last 3 numbers should be divided by 8. So let's divide it. Yes, it is getting divided by 8. So this will be divided by 8. It will get divided by 8. Yes. 9 says sum should be divisible by 9. It isn't. Is it getting divided by 9? No. 10. 10 says last number should be 0. So is last number 0? No. Divisibility by 11. 11 says we have to number it. Let's add the odd places numbers. Even places. Let's subtract it. It says the answer should be either 0 or multiple of 11. So it isn't giving us that answer. So, no. So see, in fraction of seconds, we found out all the possible numbers from 2 to 11 which can actually divide the given number completely and which cannot. So thank you for watching the video till the end and have a lovely day.